Okay, fall exam review, worksheet 7, number 1. The limit as h approaches 0 for natural log of 2x plus h minus natural log of 2x over h is. Okay, now this is not a limit problem in the sense that we work things out algebraically. Okay, this is representative of something else. Okay, this is the limit definition of a derivative, and students just need to be able to recognize that this is an expression for finding the derivative function. Okay. So from here, we need to be able to identify that this is referring, asking to find the derivative of a specific function, and this function is going to be natural log of 2x. All right, natural log of 2x, because of our formula f of x plus h minus f of x over h. So if we know that we're finding a derivative for a specific function, namely natural log of 2x, then we can avoid having to go through a limit definition. We can just go through the rules that we know. Okay. So if we're just given, if we know that this is referring to natural log of 2x and it's asking for you to find f prime of x, we just go through the rule that we know for natural log of u, which is 1 over u times u prime, or u prime over u. So our u value is 2x. So simply 1 over u times u prime. So 2 over 2x leaves you with 1 over x. Okay. Number 2, this is similar in the sense that this is starting. This is basically the notation for limit definition of a derivative. However, if you notice that the x has been replaced with a value. So beyond just asking for the derivative function, this is asking to find the derivative at a specific point. So one step more than the previous problem. Okay. But students still need to be able to identify the appropriate function that this is referring to, and this is referring to tangent of x. Okay. And it's asking to find the derivative of tangent of x at this x value. So let's go through that step. F of x is tangent of x. We know the derivative rule for tangent is secant squared x. And now we want to evaluate this derivative at this x value, pi over 4. Okay, so we just simply plug in. Replace x with pi over 4. Secant of pi over 4 is simply 2 over root 2, right? The reciprocal of cosine of pi over 4. So we squared numerator and denominator, we get 4 over 2, which is equal to 2. So answer E. Okay, number 3. Okay, we need to know the relationship between a function and its inverse, as well as the relationship of the slope between a function and its inverse at a point. Okay, so I like to set it up this way, where the first row represents the relationship between ordered pairs between the function and its inverse, and the second row representing the relationship between the derivative at a point between a function and a corresponding point for the inverse function. Okay, so f of 3 is equal to 8. So I know that if the ordered pair for the function is 3, 8, then the ordered pair, the corresponding ordered pair for the inverse function must be flip-flopped, right? Must be 8, 3. Okay, and we're trying to get to the derivative of f inverse at 8. So I'm trying to get to derivative of f inverse at 8. Okay. I know that f prime of 3 is going to give me a certain slope. So which means that the derivative of f inverse of 8 must give me the reciprocal. So that's the relationship. Okay. And if the derivative of f inverse of 8 it gives me the reciprocal 1 over m, then I can think of it as 1 over f prime of 3. Right. Okay, number 4. Let f be the function given by x over x minus 3. For what value of x is the slope of the line tangent to the graph equal to negative 4? So we're trying to figure out, the x value where the slopes are going to be equal. So we can set the derivative function equal to negative 3/4 and solve for x. So first, we need to find f prime. Quotient rule, f prime g minus f g prime all over g squared. Combine like terms in the numerator, and we're going to get negative 3 over x minus 3 squared. Okay, we're trying to find a location where the slope is going to be exactly negative 3/4. So we set our f prime function equal to negative 3/4. Cross multiply. The negative 3's will just cancel each other out after we cross multiply. So we're left with 4 is equal to x minus 3 squared. I can FOIL this out, expand, x squared minus, rewrite it with x minus 3 squared on the left side. Expand, x squared minus 6x plus 9 equals 4. We want to factor, subtract 4 from both sides, and we get x minus 5, x minus 1, so x equals 1 and x equals 5. So there's two locations on this graph where the slope to the tangent line will be exactly negative 3/4. Okay, find the inflection point. So if we want to find the inflection point, we first need to get to the second derivative. So we have to go through product and chain rule. So f prime g plus f times g prime. All this is chain rule. I can factor out the x plus 4 quantity squared, which leaves me with 2x plus 4 plus 6x, which reduces to be 8x plus 8. So this is just my first derivative. I still need to find the second derivative. So I'm going to go through chain rule and product rule again. Okay, so product rule f prime g plus f g prime. I can factor out the x plus 4 to make my simplifying a little bit easier. So all this gets me down to x plus 4 times 24x plus 48. So technically I could factor out the 24 again. But either way, I'm going to get to critical points at negative 4 and 2. So put them on a sign line, and then we test each interval with the second derivative. So if I plug negative 5, I'm going to get a positive value. If I plug in negative 3, I'll get a positive and a negative, so negative here. And then if I plug in any value greater than negative 2, I'll get 2 positives. So inflection points will occur at both negative 4 and negative 2 because there's a change in signs at each critical point. So if I plug negative 4 back into the original equation, I'm going to get 0. And if I plug negative 2 back into the original equation, I'll get negative 32. So there's actually going to be 2 inflection points. On the original exam review sheet, it's missing the second solution, so I just added it in for part B. Okay, number 5. At what value of x do the graph e to the x and x squared plus 5x have parallel tangent lines? So we can just set their derivatives equal to each other and solve for x. Okay, because we want to find out when are their derivatives equal to each other. So the first y prime is e to the x. The second y prime is going to be 2x plus 5. We set them equal to each other. Either we can graph. We're not able to solve this algebraically. So either we can graph these two lines and look for the intersection, or we can set everything equal to 0 and just look for x-intercepts. So I graphed it this way, and I'm just looking for x-intercepts to find my intersections. So negative 2.457 and 2.252. Okay, number 7. If the line tangent to f of x at point negative 3, 8 passes through negative 2, 5, then, okay, so I'm going to just show a sketch of the graph of visually what could be happening here. So we have a line that is tangent to a curve. Okay, so I drew a line through negative 3, 8. So this is the point of tangency between between the tangent line and the curve. Okay, so we know that at this point, both the curve and the line are going to share the same slope, right? And so if I can find the slope of this line, then I can also find the slope of the curve at this point. Okay. Now, what they do provide for us is that they do provide a second point where the tangent line passes. So if I have 2 points on the line, then I can easily find the slope. Right? So slope is just change in y over change in x. So I'm going to use these two lines to find, these 2 points to find my slope, which will give me negative 3. So now, since the slope of the tangent line to the curve at x equals negative 3 is negative 3, then I know that f prime of negative 3 must be equal to negative 3, right? This just says that my slope at -3 is, for my function, is going to be -3, right? Because the slope of the tangent line is -3, therefore the point of tangency to the curve will also be -3. Okay, all right. Number 8. Let f of x be x cubed minus x such that f is continuous on the closed interval. Find the critical points that satisfy the mean value theorem. Okay, so we simply set f prime of c equal to f of b minus f of a. Okay, we're trying to find the c value at which the average slope is equal to the instantaneous slope. So to find f prime of c, we need to find the derivative. So that'll give us 3x squared minus 1. And we also need to find the ordered pairs so we can actually find the average slope. So we plug -1 into the original function, and that'll get us 0. If I plug 1 to the original function, I'm also going to get 0. So my average rate of change is just changing y over change in x. So 0 over -2, which is 0. Okay, so we have our derivative. We set our derivative equal to 0 to find out the c value where my instantaneous slope is equal to the average slope. Okay, subtract 1 from both sides, divide by 3, take the square root of both sides. So there's going to be 2 c values, plus or minus root 1 over 3. And both these values fall within the interval, closed interval from -1 to 1. So that's our solution.